Hi everyone, you're welcome back to my channel. In my previous video, we take a look at 40 most likely questions in jamb 2022. You see, I have one of our students that is requesting us to post video on question on equilibrium. And today's video, I'm going to be giving you likely questions on equilibrium with an explanation, such that you can easily understand everything about equilibrium with their calculations and the theoretical aspect of it. Without taking much of our time, if you're just new to my channel, please don't forget to subscribe to my channel and like my videos. And also drop a comment in the comment box section below. Thank you. Now you see, as well to know that jamb these days does not require stress. There is no one single question that they are going to give you again in jamb that you've not seen before in your past question, either in WAEC or in NECO or in your jamb past questions that is sold to you outside there. Altogether, the only thing that it did now is just to reshuffle the question by trying to twist the question in a manner that you won't be able to understand what they are asking. Now, let's take a look at these questions. Even though they twist it for you, there's a way that you can easily answer them to understand what they are talking about. And take a look at this question, the calculative aspect of equilibrium, for a body to be in equilibrium. Now, we are going to be looking at equilibrium of forces questions. Now, the first question that I'll be looking at in this place here, we said a lorry travels 10 km northward, 4 km eastward, 6 km southward, and 4 km westward to arrive at a point T. What is the total displacement of the lorry? Now, if you follow this, they said it's moved 10 km along the north. If this is the north, you know, in your cardinal points, we have the north, south, east, and the west. Now, let's say the lorry moved for 10 km northward. This is the direction of the north. Let's say this is 10 km. Now, the next thing they said 4 km eastward. But I want you to understand something, that every vector moves in such a way that the end point of one vector is the starting point of another vector. And so you have to know that this is force, which is a vector quantity. Look at, if I have a force moving along this direction, if this is the starting point of this force, this is the end point of this force, then if I have another force F2, force F2 is going to be starting where force F1 ends. If here is where force F1 ends, then I'll be having what? Force F2 starting from that same position. If I have force F3, I'll be having it along that same what? Position. This is my F3. Now from the question here, they said it moved 10 Newton along north and then 4 km eastward, 4 km eastward. Now this is the direction of our east. From here, we have east. 4 km along this direction. Let's say here is 4 km, just estimated value. The next thing they said 6 km southward and 4 km eastward. And 4 km westward. Now, 6 km southward, this is along south. All together, now it comes like this. This is it here. Along this direction here, 6 km. Then I said, and then, 4 km westward to arrive at a point T. What is the total displacement? Then it's moved 4 km along this direction like this. 4 km from here to here like this. Altogether, this is here. From here to here is 4 km. Now, you are now asked to find the total displacement of the body. Normally, total displacement of the body is the distance of the body from the starting point to the end point of the motion. Now, this is the starting point of the motion, and this is the end point of the motion. If the total distance from here to here is 10 km, the body moved from here to here, it was 6 kilometers. Then the remaining motion, which is from here to here, will be what? That is 10 kilometers minus this 10 kilometers minus 6 kilometers. That's what will give us distance from here to here. Distance from here to here, that is the total displacement of the body, because the thing is always along a straight line. Distance moved by the body along a straight line, that's what we call what? Displacement. Now, here it is displaced, let me say 6 kilometers, 10 kilometers, which is going to give us 4 kilometers. But along which direction is the body moving? We know that our answer is 4 kilometers, but if you take a look at the options, what do we have here? Option A, we have 6 kilometers south, 4 kilometers north, 6 kilometers north, and 4 kilometers east. The body only tried to move from here to here. All this motion that it performed here, because it returned back to the initial position. So it only moved from here back to this place. Which is, if you take a look at this from our cardinal point, the body only moved 4 kilometers along north direction, which is upward. That is the answer. 4 kilometers along north direction. Sometime, the question might come like this for you in exam, whereby I'll be having, let me say, 10 kilometers. It moved 4 kilometers along east. Let's say 6 kilometers back here. Then it moved only 3 kilometers to this direction. Now, okay, it cannot even move in this direction. It stopped here. Let's say it stopped in this place here, 6 kilometers. You are now asked to calculate for the total displacement of the body. Don't forget that displacement from the starting point to the end point. I can only trace this thing like this and move this point back to this point here. Whereby my displacement will now be from here to here, which is saying total distance here minus distance from here to here. That is the displacement of the body. These are likely questions that normally twist for you in what? In exam. All together. Now let's take a look at the next question that is there. Question number 2. We said two forces whose resultant is 100 Newton. Two forces whose resultant is 100 Newton are at right angle to each other. Now, let me assume that this is force F1, and this one is force F2. They are at an angle of 90 degrees, that is right angle to each other. If one of them makes an angle of 30 degrees with the resultant, normally the resultant of this force should be the diagonal, which is from here. Now, if this is my resultant, all together, now, they said one of them makes an angle of 30 degrees with the resultant, determine its magnitude. Now, take a look at this. I assume that this is my resultant. The angle that this force here makes with the resultant is 30 degrees. 30 degrees. The value of the resultant is 100 Newton. These are the two forces, force F1 and F2. So you can as well as say that it is force F1 that makes an angle of 30 degrees. You can either use here or use here. So if I assume that this force F1 that makes an angle which is 30 degrees, or I can also use here. Here, if I use here, there will be 60 degrees. But here I'm assuming force F2, which is parallel to this place here. You can take here to be force F1, anything you like. Now, if force F2 make an angle of 30 degrees, the resultant of the force is 100 Newton. The only thing you need to do here is drop this thing down. If you drop it down here, you know we have a right angle here. Now, what I want to find, we have to find the magnitude of this force that makes an angle of 30 degrees. How do you find the magnitude? Using Pythagoras theorem. Using what? Sine trigonometric ratio. We have angles here, we have the adjacent, and I also have the hypotenuse. Now, if I have my adjacent and my hypotenuse, what did I use? Normally, since adjacent and hypotenuse give rise to cosine of angle. Adjacent and hypotenuse give rise to what? Cosine of angle. As soon as I have opposites and hypotenuse, it gives rise to sine of angle. So from here, it's shown that I'm going to be using cosine of angle to solve this. So if I have cosine of 30 degrees, which will be equals to adjacent, which is my F2, all over hypotenuse, which is 100 Newton. Now, you know your calculator that you're going to be given in JAMB, there is nothing like 30 degrees. But from here, my F2 equals 100 cos 30 degree. Now, depends on the way the answer is given to you. But if I check the options here, the option is in decimal points. I'm going to be giving you something. You see, normally, cosine of all these 30 degree are special angle. 30, 45, 60, they are special angle, which are the angles that is going to be given to you. Now, we know that sine 30 is 0.5, while cos 30 is equal to 0.866, or in short form, root 3 over 2, while this one is 1 over 2. And we also know that what sine 45 and cos 45 give rise to the same thing, which is root 2 over 2, and this one is what? Root 2 over 2, or it is equals to 0.70 something. That's what we're going to be getting for all this, the same value. Now, in this case here, sine 60 and sine 30, they are reversed. If sine 30 is 0.5, sorry, if cos 30 is 0.866, sine 60 is also 0.866, which is the same thing as root 3 all over 2, and cos 60 will be equal to 0.5, which is equal to 1 over 2. That means this is equivalent to this, while this is equivalent to this. Altogether, these are special angles that you are expected to know for your jamb. Just know all this. Now, how do we go about this? So from here, we know that my cos 30, this is my F2. F2 is going to give me 100 times cos 30. Cos 30 is 0.866, which is going to give us what? 86.6 Newton. That is my answer. If you multiply 100 times 0.866, I'll be having 86.6 Newton. These are another likely question, but sometimes they may tend to twist this question for you. As you ought to know that they are going to set question on equilibrium. It is certain. And they are going to set question on what? Motion. All these things are certainty that you are going to see them all together. But the way they set the question matters. That is number 2. Now let's take a look at question 3. I'm going to be removing this. So if you take a look at the third question that I have for you here, that one also look quite simple, but it is difficult. They said a force of 5 Newton acts at a point Y. Now, we have a line given to us here. They say a force of 5 Newton acts at a point Y on a rod SYZ. This is the rod S, Y, and Z. The force is now acting at this point Y. This is the force 5 Newton. 5 Newton acting at this point Y here. Then I said it's shown in the diagram above. If SY is 2 meters, the distance from here to here is 2 meters. That's what is given to us. What is the moment of the force about what is the moment of the force about point X? That means, what is the moment of this force that is acting here about point S? What will be the moment? The first thing I need to know here is that what? If you are solving question on moment, you need the definition of moment. Moment may simply be defined as the force, as the product of the force times perpendicular distance from the point of action of the force. Altogether, that means before you can have moment, let me say I have a body like this. Moment is just like a twisting, a turning effect that is used to turn a body. Now, it is impossible for me to turn, I want to turn something about this point. It is impossible for me to push it like this to turn. I can only turn this thing to move along an angle in an angle like this by either adding a force that is acting downward or a force that is acting upward to the what? Parallel to the horizontal direction. That is the only way I can resolve the moment about this. But if you check this force here, the line of action of the force and the force are the same. Please note, if the line of action of the force and the force are in the same direction, then the total moment acting on that force will be equal to 0. There is no moment there. Forget about the distance that they get to you here. Some students are going to fall into this trap. The distance here is 2 meters, and the force here is what? There is force. And we know that moment is force times distance. As we want to see, let me give you the option that is there. Option A, we have 0 Newton meter. Option B, we have 3 Newton meter. Option C, we have 7 Newton meter. And option D, we have 10 Newton meter. That 10 Newton meter is from here that we know that moment is equal to force times distance. Since the force here is 5, I mean, distance is equals to 2 meter, which is going to give rise to what? 10 Newton meter. But in this case here, in this place here, we have, there is no force in this place. Sorry, there is force, but the force is not acting perpendicularly. Automatically, my moment should be equals to 0 Newton meter. That is the answer to this. All together, that is another this thing I want you to know. Now, the next question that I'm going to be giving you here again under equilibrium of forces is this. This question that they said also, they said a body of weight W Newton rests on a smooth plane inclined at an angle theta degree to the horizontal. This is the inclined plane. We now have a body that is here. The weight of the body is W Newton. Altogether, it rests on this inclined plane. Now, the inclined plane makes an angle of theta degree, with the horizontal. Now, then I said, what is the result part of the weight in Newton along the plane? This one you don't even need to do this thing. You should also know that, but I'm going to give you this in case of your next exam. Just take it direct. Now, from here, we have to find the result part of, because look at, normally weight of a body is meant to act vertically downward, and normal reaction acting on the body, normal reaction is meant to act perpendicular to the surface of the body like this. Now, if the normal reaction on this weight, on this body, is acting perpendicularly, normally for the body to be in equilibrium, the normal reaction must balance the weight. And since this weight is supposed to act vertically downward, if I have horizontal line, it's meant to act like this, but the weight is not acting like this because of the inclination. Automatically, this weight is having a component that will balance the normal reaction. Now, if the normal reaction is upward, the component will be downward. Now, this same weight also have another component. The function of this component that is here is to allow the body to drift downward. That is the component of the weight along the plane. Now, component of the weight perpendicular to the plane, this is it here. Now, since you know that here is theta, automatically, if you look at this triangle structure, angle here also be equals to theta. Then I'll be having this thing here, I'm going to be having something of this kind. This is my total reaction. This is my vertical component. This is my horizontal. If here is W, here is theta, we have to find this place here is indicating the component of the weight along the plane. Now, how do we find the component here? Normally, if I look at this in mathematics, since let me say here is W along the normal and WP along the plane. Now, from here, if you take a look at this, I have that this thing is opposite, this angle here is opposite to this. This is hypotenuse. I know this, I don't know this, and I don't know this. Then I say that what sine of this angle equals to opposite over hypotenuse, which is going to give us WP to be equals to W sine theta. It simply shows that the component of the weight along the plane is W sine theta, while the component of the weight perpendicular to the plane, which is your normal reaction, is always equals to W cos theta. So this one is perpendicular to the plane, but in downward direction. This one is along the plane that allows the body to drift downward. This is another question that is found under what? Equilibrium of forces. But this one can also be related into frictional force. If you are given that this surface has a friction in it, then automatically we can ask to find the coefficient of that friction, whereby the coefficient of that friction should be the frictional force all over the world, the normal reaction. As you ought to know that normally the frictional force that is acting on the body will be upward like this to balance the reaction, to balance the component of the weight downward. So hereby the frictional force is the same thing as the weight along the plane, which is equal to this. Automatically the coefficient of friction can be equal to W sine theta from here, which is equal to your frictional force, all over W cos theta, my normal reaction. Then this can remove this to give us sine theta over cos theta, which is equal to tan theta. Automatically, if you are given question on inclined plane, and you are now asked to calculate the coefficient of friction, don't stress yourself to use this formula. Just go straight to what? Tan of the angle. That is all about that. Now, the next question, let me say the fourth question that I have for you here, is also on equilibrium of forces. But look at this here. This one is, I have something interesting here. We are given that in the diagram. Sorry, the diagram shows forces 4 Newton, 6 Newton, 10 Newton, blah 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 blah. Now, we have the diagram show this. We have this force here. Sorry, let me try to draw the diagram very well. I'm given this, and I'm given the horizontal forces that is here. Then we are given another force that is acting along this direction. Here is 10 Newton, and this side is 8 Newton, and here we have 6 Newton force that is acting here. Then the last one here should be 4 Newton. We are now asked to find, so I said, the net horizontal force is, now when I said net horizontal force, simply means what with the summation of the horizontal forces. I want to know that normally we have 10 Newton along this direction, 4 Newton along this direction. But you see these two forces, they are inclined at an angle that is not well known to us. Sorry, there is no angle here, so this question is kind of not correct. They don't give us any angle in this place. So let's remove this. Now, take a look at this one here. I have here this, we have this, and I have this. Now, the force acting on this is 5 Newton here, R, and I have here Q. I have here to be equals to P, and then that's all. Here is 2 Newton, and this is 4 Newton. Now, look at this question that is here. They said, if the system above is in equilibrium, the tension in the string Q is what? Now, normally, if you have a body that is tied with a string to a fixed point, normally if I have the body like this, if the weight of the body is acting downward, the tension is the force that is holding the string. All together. Now, the tension in this string here now automatically is this. It will be normally it's supposed to be acting upward like this, which will balance the weight of the body. Now, the arrow determines what you have to find. Here they ask you to find the tension in this string Q. But each of these strings has different tension. Whereby the one that will have the highest tension is the string that is above everything. The weight above is going to have what? Highest tension, while the one below is going to have the least tension. How is it going to be like that? Normally, the tension that is found in this place here, you know that what you are giving here is the weight. Weight. All together. Now, tension on this string here depends on, since I said the tension must be equal to the weight of the body. All together. Now, the tension that is acting on P is equal to the summation of weight that is acting on it. Now, what is the total weight acting on this P here? Total weight acting on P is weight 2 Newton, weight 4 Newton is on P, and what? Weight 5 Newton. All these three weights, they are acting on this rope only. This rope is not carrying all this weight here. So the tension P will be equals to 2 plus 4 plus 5. Altogether, which is equals to 11 Newton. Now, tension in Q, the only weight that is acting on Q, first Q, is this what? Weight on Q should be equals to, from here to here, we have what? This weight that is acting on it, and this weight that is acting on it. Altogether, so its own weight, the weight that is acting on this tension, this is the rope here, tension in Q here, this rope here, the force acting on it is its own weight and the weight that is below it. So the tension in Q should be equal to 4 plus 5 Newton, which is equal to 9 Newton. What about that in R? In this R here, it is only this weight that is acting on R. Altogether, since you know that what tension is an upward force, and for a body to be in equilibrium, an upward force must balance downward force. So the only downward force that we have that is acting on R is 5 Newton. So tension on R should be equal to 5 Newton, which is balanced like that. Now, what is the question I'm now asking you? If you now check the option, all these things are in the options. Altogether, now they said option A, 6 Newton, 4 Newton, 11 Newton, which is option C, and 9 Newton, which is option D. So our answer should be equal to what? Tension in Q should be equal to 9 Newton, which is our option D. So if you want to solve it, you need to solve with what? Knowledge. Altogether, as you know that our tension depends on the force below it. So if here is the rope, then the force below it will determine the tension. If this is the rope, the forces below it will determine the tension. This is the rope, the force below it. Altogether, that is another question under that. Now, take a look at another question that is related to the one that I want to explain before. This is the question also on equilibrium of forces. Let me go like this. We are given this. Here is 15, and here we are given what? Something of this kind. Here I have 5, 0, 5, 0, and here the force here is 200 Newton, 45, 40 Newton, and here is 50. Now, this is uniform beam. This is a uniform beam. So look at the question given to you here. They said, in the diagram above, a rod 50 centimeters long of uniform cross section is suspended horizontally on a fulcrum F. This is the fulcrum F. By the action of two forces, what is the weight of the rod? Now, you have to find the weight of this rod. As well to know that what the weight of a body should be situated at the center of gravity of that body. Altogether, the center of gravity of a rod, since rod is a uniform bar, then the center of gravity of a rod should be at the center point here, which is at point 25. You see these numbers that I see here, it simply means the distance from here to here is 5. You know, here is 0. This is a ruler. 0 from here to here is 5. From here to this place is 15. That's what they mean. Now, this is, if here is the center point, then the distance from here to the center point is 25. And from here to this place is 50. From 0 to 45, this is 45 meters. Anyone? Now, you are asked to find the weight. Don't forget that the weight of the body should be acting here, which is W. This is the weight of the body. Now, how do we not calculate for the weight of the body? I can easily get the weight of the body in this way. You know, normally, each of these body has weight with respect to has distance from the fulcrum. So the first thing I need to do is that you further calculate what is the distance of this force of 200 Newton. You find the distance of force of 200 Newton from the fulcrum and the distance of 40 Newton from the fulcrum. Now, if from here to here is 5 Newton, now the distance between here and here should be 15 minus 5 from here to here. That is equal to 10 meter, or let's say in centimeter, anyone. Now, the distance between the weight and here should be equal to 25 minus 15. That should give rise to also 10 meter. What about the distance from here, this force here, to the fulcrum? See, the point of this force here is 45, the fulcrum is 15. Distance from here to here should be 45 minus 15, which is going to give us what? that should be 30. So from here to here is 30. Let's take it like this. From here to this place here is equals to 30 meter. Now, the reason why I'm looking for this distance is because if you want to calculate moment is always the product of your force times your distance. So if I calculate this distance, I can easily find the force to get the weight. Now, how can I find my weight here now? Applying the principle of moment that said anti-clockwise moment should be equals to clockwise moment. Now, how do we get our anti-clockwise moment? Normally, look at this weight here is acting downward. This also acting downward. Now, this body, this force that is here, we tend to turn this body across this direction. It's going to what? Turn this body along this direction, which is an anti-clockwise manner. This force here, the weight of the body, we tend to return it back here for the body to be in equilibrium. Likewise, this force we tend to bring it along direction. These two forces are in clockwise manner. While this one is in what? Anti-clockwise manner. So for this body to be in equilibrium, total clockwise moment must be equal to total anti-clockwise moment. Now let's solve it. Moment of this force should be equal to 200 times its distance, which is 10. It should be equal to moment of this one what? W times 10. That is for this. Plus this one, these two are clockwise. So I'm going to add them together. Plus 40 times, let me take it like this. 40 times, distance from here to here is 30. Now I'm going to be having, there is a mistake here. 40 times 30 is going to give us 1,200, not 120. Now, I'll be having this 10W to be equal to 2,000 minus 1,200, which is going to give us 800. Now, dividing by 10, I should be having my weight to be equal to 80 Newton. That is the weight of the body from this place here. Now, that is question under equilibrium. Likely, they might tend to change this. They will just give that what? A uniform meter rule. Whenever they said a uniform meter rule, not something that they are referring to, and they didn't give you length, then they are referring to the total length to be equal to 100 centimeter. A uniform meter rule has 100 centimeter as its total length. If you are not given any length, please note that. Now, let's take a look at this. Let's look at the next question. I think many students confuse this kind of question. They tend to put question on equilibrium, condition for equilibrium, for condition for coplanar forces, which are different. Take a look at this. They said all three forces must be concurrent. All three forces must be concurrent. All three forces must be concurrent. That is I. The upward force is equal to downward force. The upward force is equal downward force. We have the algebraic sum of the moment about any point must be 0. The algebraic sum of the moments about any points must be 0. And then the last one, that's all. Now I said, which of the above conditions must hold for a body acted upon by a system of 3 coplanar forces in equilibrium? Now, what are coplanar forces? Coplanar forces are forces that act on the same plane. Majorly, we have something of this kind. These are what coplanar forces. I have force F1 that is acting here, force F2 that is acting here, and my force F3. Now, these are this thing here. Normally, for a body to be in, if this is the body that they are acted upon on. Now, for this body to be in equilibrium, number one, the three forces must be concurrent. What by concurrent of the three forces? This force here, these three forces are coming out from the same point, or they are acting on the same point, then the three of them are what? Concurrent. Automatically, option I is correct. That is the first condition. All the three forces must be concurrent for them to be coplanar. Now, the second condition that is here, they said they are doing some blah 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 blah. Now, not something that moments only act when there is distance. When they do not give you distance, you don't have anything about these moments. Altogether, now, the second one said the upward force is equal to downward force. Yes. If I resolve these two forces are going to give me the resultants, which is going to balance this. This force F3 is known as this equilibrium force. So an equilibrium force is a downward force, while the resultant force is an upward force. So resultant force should balance the equilibrium force. So the two conditions for a body to be in equilibrium under three coplanar forces is 1 and 2. But for a body to be in equilibrium under what? Parallel forces. All together, these are what we call parallel forces. Assuming I have a body here, I have a force here, another one here. We now have what? This, which is the fulcrum. Now, this body is going to be in equilibrium using two conditions. What is the condition? Summation of the forces must be 0. Which forces? Upward force must equal to downward force. If this is downward force, this is upward force, the two forces must balance each other. Then the second thing is summation of the moment. Summation of moment must also be equals 0. That means clockwise moment must be equal to anti-clockwise moment. This one is for parallel forces. Altogether, the body is acted upon by parallel forces. But if the body is acted upon by coplanar forces, which is this here, then these two conditions will hold. So our answer to that is option I and II. I hope I make this thing clear to you so that you can understand this on equilibrium. These are questions, likely questions on what equilibrium. Then, I think let me give you this last one, which is the last one but not the least. They said they can ask you under the application of equilibrium, which is stability. Stability. Now, they can say that what? Which of the following bodies are stable? You know that we can have different kinds of equilibrium. We can have a stable, unstable equilibrium, and a neutral equilibrium. These are the three types of equilibrium that we have. Now, we are given, they can draw a diagram for you. Like, I have something of this kind. All these things are always what repeated. We have something of this kind also is given to us. I have something of this kind, like your normal ice cream that normally give us when we are at home. I have this one. Now, each of this body, you ask which of them is in equilibrium. Let me try to analyze it for you. For a body to be in equilibrium, the center of gravity of the body must, if this body tends to twist like this, altogether, the center of gravity of this body will shift to another position. Altogether, now, this body has high center of gravity. A body with high center of gravity is unstable. Unstable. Because normally the center of gravity of the body should be very close to where the base is large. For example, look at this base that is large here. The center of gravity of this body is very closer to the larger base. Because the body that have larger base will tend to balance than a body that have what? Very little base. Now, this body here has low center of gravity. So a body with low center of gravity is stable. Stable. Altogether, now, why a body with high center of gravity is what? Unstable. That's why they can give you the application now what? Equilibrium is most applicable in racing car. Because of why? That means, why is it that the base of the wheel of a racing car is made larger? The reason why they make it to be large is so that that racing car can have low center of gravity, such that all the whole weight of the car will be below. And if the weight is below, the car will be stable when running. Altogether, that is one thing. Normal human being, like for example, now there are some people, for example, those that are tall, they have high center of gravity. Altogether, bodies that are short, they have what? Low center of gravity. Come here with me. Now, this thing also what determines players in football also. So, because of their center of gravity, it creates instability. When the center of gravity is higher, then there is what? Instability. That's what is happening here. A body that is standing on a base, on a tiny base like this, will have high center of gravity. A body that is sitting with the base will have low center of gravity and what? Stable. Why this body here does not what? Balance. It is what? It can move to anywhere. This thing can roll one direction or the other direction. So this one is in neutral equilibrium. Altogether, it is in neutral equilibrium. Altogether, so these are the likely things that you can see in what? Equilibrium. I try to brief everything on equilibrium for you so that you can what? Understand this. Thanks for watching this video. Please try to subscribe to my channel and click on the like button to like my videos and share. Don't forget to share to your friend and comment. Thanks.